We are not too many, so I propose that we make a very brief introduction round. If you like, please switch on your camera and your audio and let us know your name and institution.
Who's going to start?
In the order of pictures. Michael, go ahead.
So, hello, my name is Michael Hügler. I'm from TZW, and together with my colleague Stefan Stauder, we prepared a presentation about a drinking water supply in the region, in the upper catchment.
Christian.
Hello, my name is Christian Leon from the University of Stuttgart, colleague from Anna Kolov, and I'm the coordinator of the Trust project.
Hanna.
My name is Hanna Kramer. I'm also from the University of Stuttgart, working for the Institute of Sanitary Engineering, Water Quality and Solid Waste Management. And I prepared a short presentation about reuse solution in the village in Tubicocha.
All right. Fabienne, please.
Okay, hi, I'm Fabienne. I'm a sociological researcher at the University of Stuttgart. It's serious also, and I work together with Christian and Hanna. And the presentation that we've prepared today is about the communal organizations in Peruvian water governance and what challenges they face.
Perfect. Now we have a list of participants. I don't know if you can see it. We have Annika from Adelphi. Would you like to switch your camera on? Okay. I'm unsure. Anybody else? Just jump in and switch your camera and your audio on and say hello. I see that there are many people.
I'm not sure. My colleague Stefan doesn't get the audio yet, so I don't know how this is with the other participant. I hope they get it.
Lilith, we only see the presenters' videos. I don't know why.
Yeah, that's because only the presenters turn their videos on. So, yes. I mean, everybody should be able to turn his video and camera on. I mean, this video and audio on as he likes. I mean, if not, we can continue later.
Okay, what a pity. Then let's try to have the rest of the introduction round after the presentations. Good. So let's go back to the presentation mode. Lilith, could you do that, please? Thank you. And we will hear 3 presentations. I propose that we go through the 3 inputs that we have without direct questions immediately after the talks, but to save time for a big joint discussion at the end. That gives us around half an hour. So please don't forget your questions. You're also invited to use the chat function immediately. So just type in your questions and your comments, and Christian Leon will bring them to the plenary after the talks. So let's start with the first talk. Fabienne, the floor is yours. Thank you.
Okay, so I hope you can all hear me well. I welcome you to the presentation about the challenges and solutions of communal water organization in the Peruvian water sector. Let me first begin by illustrating the role of communal organizations to achieve the SDG6 to ensure access to clean water and sanitation for all in Peru. As you can see, the situation for rural areas is much more precarious than for urban areas. Drinking water supply through public networks is lower in rural areas, as well as the amount of chlorination of water that is occurring. There's also less access to public sewage system in rural areas than in urban areas, so there is a considerable disadvantage of the rural areas. However, there is an important aspect of the Peruvian water sector, that is that there is, besides the state and the market, also many communal organizations that are active in providing water services in those rural areas. This raises the questions what the contribution of such communal organizations can be to the water services in Peru, what challenges they face, and how they can be strengthened in their functioning. Actually, there are about 25,000 communal water organizations active in Peru that supply almost 90% of the rural population. Of these, the most common organizational form are the HAS, which is short for Juntas Administradoras de Servicios de Saneamiento, which can be translated as Management Board for Sanitation Services. In general, these communal organizations have contributed a lot to the supply of the remote rural areas where neither state nor market could provide water services. They were originally rooted in informal traditions of self-governance, but have since been recognized by the Peruvian law. For many years, they have been supported through NGOs and international corporations, but in the process of formalizing them as service providers, they have also received increasing financial and institutional support. So, how do such communal organizations work? First of all, they are civil associations, so different from state and market organizations, that are based on the principles of self-governance, in which the members themselves run the water services. The members are responsible for building, managing the systems, and also treating the drinking water. Besides, they administrate the organization, hold elections and assemblies. To receive services, the members pay a monthly fee for the services and also contribute their labor and manpower. While the communal organizations are mostly based on voluntary work, they can also employ operators for the technical everyday tasks. Let me now present you our case study on which we base our presentations. While the TRUST project took place in the whole catchment part of the Lorraine River, we focus here on the mountain village San Andrés de Tubicocha. The district San Andrés de Tubicocha is located in the province of Lima, at an altitude of about 3,500 meters above sea level, and they live at about 1,400 people in the district, of which almost 800 live in the village center on which we focus our study. There is an average rainfall from about 300 millimeters per year with an average temperature of 9 degrees Celsius. There's a rainy season from December to March and a dry season from June to September. The community is rural and the economic activities are mostly agrarian. The sanitation services are provided by a communal organization of the aforementioned HAS type. Let me now present you the most pressing challenges that the HAS in San Andrés de Tubicocha face. Those are also challenges that are typical for many other HAS that are active in Peru. First of all, the water quality is impaired due to an inadequate chlorination as well as the presence of sediments in the water and a faulty infrastructure. Besides, the monitoring of the water quality is impaired as well. In the dry season, they also face episodes of water shortage, and generally there's a lower importance for wastewater issues than for drinking water issues. Those problems stem partly from some deficiencies in the functioning of the HAS. That is that, first of all, they need to improve their technical capacities and to continuously ask for better technical support, especially concerning chlorination. Their financial situation is unstable due to some members' low willingness to pay the monthly fees. They also show some administrative deficiencies like meeting the prescribed gender quotas. This also stems from the problem that there's a high workload for the members, especially for those members that work in the board of the administration, since they carry out their functions on a voluntary basis and are not professionals in this field. Besides, it seems that the population is dissatisfied with the quality of the water services, and the HAS is not highly valued in the community. There are also various external factors that affect the functioning of the HAS. There are, for example, many bureaucratic hurdles that it has faces, for example, during registration or to solicit funding. They also feel that they lack consistent political support and that water issues often no priorities on the different governance levels. Additionally, the responsibilities and duties are often not assigned clearly. For example, the monitoring of water quality is often deferred to other actors. Furthermore, the catchment area and its governance are highly fragmented, and the cooperation between the different actors as well as the different levels is often inadequate. Finally, the impacts of climate change may further increase the problems that it has already facing, for example, through more dry periods or heavier rainfall. Those reasons also affect the function of the HAS and impede them to plan and implement more long-term strategies. As we have seen, those communal organizations play an important role in the provision of water and water sanitation services, and they are often historically rooted in their communities. They possess valuable knowledge, and that makes them vital actors that need to be included in decision-making. Such inclusion of local actors, oh, excuse me, that was one too quick. Such inclusion of local actors in decision process was an important part of the participatory approaches that we followed in this project. In our project, an important focus was on developing socio-technical concepts that were adapted to local conditions. We therefore promoted a dialogue-oriented and community-based approach to assess these concepts and iterated the evaluation between experts and local stakeholders. Pilot and capacitation plans were planned to implement the concepts on a smaller scale, to test them under local conditions, and to permit the knowledge transfer as well as capacity building. To encourage a more sustained approach, it was important to tackle the fragmentation that we found in the sector and in the catchment area. We therefore identified the relevant stakeholders and involved them in the project through participation processes, therefore permitting and facilitating exchange between them. Cooperating with local NGOs also proved to be very helpful for offering a sustained local support, and developing guidelines of the lessons learned also will help to assist in making the findings and results more accessible to other actors and communities, and therefore facilitate a spatial and temporal transfer of knowledge. In long term, participation processes can contribute to raise environmental awareness and enhance the appreciation for water issues, as well as for the work that the communal organizations do. So, to conclude, let me just say that communal water actors are valuable organizations that provide water services in rural areas, facing a multitude and complex internal and external challenges. Since they are very important for the provision of services in rural areas and therefore also to achieve the SDG6, they must be further strengthened, for example, by improving the water quality, the technical capacities, as well as their economic models. However, also state and market need to adapt their roles and support communal organizations. It is essential that there is a permanent and consistent political priority for water issues on the different governance levels. It is therefore also important to actively counteract the fragmentation of water governance so that the various actors can create synergies on working on different governance levels, and thereby also strengthening the already existing multi-level institutions that support communal organizations. Ultimately, it is important to continue to educate and sensitize people for water issues and thereby promoting a water culture. Such environmental awareness can lead in turn to greater appreciation of communal water organizations and for the work they do. That concludes my presentation. I thank you very much for your attention, and I look forward to discussing your comments later on.
Thank you very much, Fabienne. So please keep your questions and comments in mind for the later discussion, and you are invited to put them into the chat if you like. Michael, are you ready?
Yes. So hello again. And I, after Fabienne's introduction to the area where we did our research, I would like to focus now on the drinking water sector of this village, Tubicocha, San Andres de Tubicocha in the Peruvian mountains. So we prepared this presentation together with my colleague Stefan Stauder and also with the input of other colleagues from the whole trust community. So traditionally, the Tubicocha, the people used spring water as their drinking water source, but a couple of years ago they built up a drinking water supply system in the village by themselves in a community-based approach, and now they are delivering the drinking water of 2 reservoirs where they store the rainwater, and they use this stored rainwater as drinking water for the villages. They don't use the reservoir water directly, but the reservoir water is filtrated through the dam of the reservoir. You see here in the lower picture, you see the reservoir and the dam, and the leachate of this dam is used and pumped to is transferred to the not pumped, but it's transferred by gravity to the village of Tubicocha. So, sorry, I have some. So on this slide, you see here the village of Tubicocha. Sorry. And the first reservoir is the Ururi reservoir. This is the main reservoir of Tubicocha, which they mainly use. It is about 5 kilometers or so in distance from Tubicocha. And as a backup, they have a second reservoir, the reservoir Tubicocha, which is very remote. So it's very hard to get there. And it's about 25 more kilometers. So they built up a pipe system through the Andean mountains. And of course, there is a lot of pressure difference because from the high 4,400 to 3,600, so they have several open shafts that the pressure should be released. And of course, these tanks also bring problems with regard to contamination. In Tubicocha, the reservoir water is then collected in the drinking water tank, which is shown as this picture, and then delivered directly to the village with a PVC distribution system. And as Fabienne already said, this whole system is operated by the HAS. So they have already some disinfection possibility on this drinking water reservoir. As you see here on this drinking water tank, you see a little building on this tank, and they had a chlorination station there. But during all our visits, we didn't see that this chlorination is working, and so there are several problems which I come back later to why they have the impaired drinking water quality in this village. So we analyzed the water quality of the raw water, which is the reservoir water of the Ururi Lake and also of the Tubicocha reservoir. We analyzed the drinking water quality of the spring, which is mostly used for drinking water in the village itself, and of course of the network. During several visits, we took sample and we analyzed them in our laboratory. In generally, the drinking water quality from the physicochemical point is very good, and occasionally we see high turbidity, which is of course also related to the rainy season mostly, so there can be high turbidity values which impair the drinking water quality, of course. And also what we see here on the lower part of this slide, you see the microbiological parameters. So we frequently detected hygienic relevance bacteria, that means fecal indicator bacteria like E. coli, especially in the leachate of the reservoir, not in the reservoir itself, and also then of course in the Tubicocha distribution system. So we detected the E. coli, for example, and the Rococci, also a fecal indicator bacterium, and also Clostridium perfringens. This is an indicator for pathogens which are chlorine resistant, for the protozoan pathogens. We also detected somatic coliphages, which are a viral indicator. So we presume from these results that there are pathogens in the drinking water in Tubicocha, and they can of course lead to mainly gastrointestinal diseases in the village if the people drink this water untreated. So one main reason for the pollution is that although they have sort of a leachate, which is somehow protected, that the reservoir water is already clean through leaching through the dam. In this area, you see on the picture here that there are sheep grazing in this area where the leachate is collected, and of course the sheep they contribute to the pollution of the water. So there is an obvious problem that the people are aware of, but they don't really have a solution for that at the moment. So getting in summary on this thing, we have on the water quality, we have a good physical chemical water quality, but we have the presence of fecal bacteria. So, and seasonally, especially during the rainy seasons, which we have very high turbidity, and there is a lot of turbidity coming out of the pipes directly. So we have no protection against the contamination in the reservoirs themselves. And as you see, the livestock is directly grazing there, so there is contamination coming from the livestock. And this frequent contamination in the supply of Tubicocha shows that there is, of course, the possibility that the people get ill by drinking the water. So with regard to the SDG6 evaluation, we cannot say that the community of Tubicocha has safely managed water. So with the water supply system, the people have access to water, and they don't need a lot of time to collect the water. So there's definitely less than 30 minutes which they needed for collecting of the water. So most of the houses, they have a own tap, and some of the houses still collect the water from the springs, for example, or from public taps. But the water quality is can somehow be in the unimproved section maybe. So this is unprotected. The wells are, or the sheets, they're open, so surface water can go into the system, and that's why we detect frequently the pathogenic microorganisms or the indicator organisms. So there is a possibility, of course, for improving the system. So the main findings here. So in order to have a good water supply systems, many Peruvian villages, they use now the dams or reservoir and long distance feeding pipes, so that they have more water available, not only the local springs, and this of course improved the quantity of water which is present in the village. But the surface water, they are of course open, and so they are prone to contamination mainly by the animals which are grazing there and which are drinking the water there. So, and during the rainy season mostly, there's a lot of introduction of soil material, so we have a really high turbidity in the water, which of course is a problem when treating the water. So, as I said, this is particularly critical in the rainy season. So with regard to the chlorine-resistant pathogens, like for example protozoa, so we cannot simply use chlorination. This is not sufficient to have a safe drinking water quality here. And also UV light alone as a disinfection measure is not sufficient, because we have occasionally high turbidity, and the high turbidity is of course influencing the UV disinfection. So what we need there is a particle removal system, like a simple filtration, for example, for the protection of the raw water, and of course the protection of the raw water resources. So the drinking water reservoirs should not be, the animals should not be able to enter actually the drinking water reservoirs. So then that would be one main thing for the protection of the drinking water raw water quality. And then the drinking water in Tubicocha itself should be treated to ensure an hygienic, safe drinking water. So this is already somehow known by the population of Tubicocha, and because with the different interviews that the trust team did there, we found out that there is already the knowledge there why the water is, for example, contaminated, and they had in former times already some water treatment installed into Tubicocha. We found signs of a former sand filter, and of course the drip chlorination was installed on the water tank, but this did not work anymore. So the main challenging is that there is a lack of qualification and training for the people of Tubicocha to operate and maintain these devices for drinking water treatment. And there is very important now supply of consumable. So sometimes they get, as they said, sometimes they get chlorine for the chlorination, but if it's used, then they stop chlorination. And of course, and as another factor is the financing. So the water is sold by the Chas, and they have a fixed price per household. And some people don't pay the price, and there is no water metering, so the people are not paying water as they use it. So these are problems which we see, and these problems must be addressed together with the village of Tubicocha and with the people living there to get a good water supply in order to meet the SDG goals. It should be pointed out that the people are aware of the problematic drinking water quality, and they usually boil the water before drinking it. So this boiling, of course, helps that pathogens which are present, which can be present in the water, they are inactivated, so that people don't get ill. So it's a traditional boiling, of course, and this is one has to focus that it is still important that the people boil the water in order to prevent them from getting ill. So within the Trust project, finally, we now developed together in workshops with the community in Tubicocha a system for the treatment of the water of Tubicocha, and this is presented here in the last slide. So we have a pilot training plant which we planned for the drinking water treatment of Tubicocha. Basically, in these mountain villages, one has to rely on very simple methodology. So the thing which we planned was a simple treatment of basically two filtering system, a rapid sand filter and a slow sand filter. So the rapid sand filter is very important in order to get rid of the occasionally high turbidities, especially during the rainy season. So otherwise the sand filter will always be clogged. So, and this is probably a problem why it didn't work in former times. The sand filter was clogged, and then the people didn't know how to clean it or something like that, and then it was removed. So you need a pre-filter, which could be a rapid sand filter, and in order to get rid of the high turbidity, and then you transfer the water to the slow sand filter, and this slow sand filter filters out the microorganisms. So in the end, you get a microbially hygienically clean water, so you can use it directly for drinking. As another precaution, it would be good, of course, that you still have a chlorination at the end of this treatment. That's a further safety step for the village. So we planned this pilot and training plant, and we wanted to install it in Tubicocha actually last spring. But as you all know, the COVID pandemic occurred, and so we couldn't fly to Tubicocha and to install this treatment plant, and we are still struggling now presently how we do it, and it's still open that because we don't know when we can of course go back to Peru and still finish the work there. So this is the present stand. There is a solution, and we wanted to install this training plant together with the people in Tubicocha, that they can see the plant, that they can see how it works, and that they can really help on installing it, and then that they could see how the drinking water can be improved. So with that, I want to end, and thanks, and I'm looking forward to the discussion after the third talk.
Thank you very much, Michael. Hannah, our last talk, wastewater, please.
Okay. Now, after the presentation of the situation on drinking water in Tubicocha, I would like to give you a short insight into the current wastewater situation in Tubicocha and possible enhancements. Okay, if you look at the actual situation in rural communities in the Lorraine Valley, we see that connection rates to a public sewer system vary between 37% and 73%. This is according to national census data from 2017. At the other end of the spectrum, open defecation, meaning fields, bushes, water bodies, remote areas, open spaces, this is still practiced between 13 and 50%. And however, only about 40% of the population was surveyed, and the distribution between the remote areas and the village centers is not totally clear. Nevertheless, it can be assumed that in the village centers are more likely to be connected to a sewer system, and open defecation is more common in the remote areas. If we take a closer look at the district San Andrés y Tubicocha, we see that around 50% of the population have access to a sewer system. This is either shared or not shared. Close to 20% use latrines or cesspits, and still above 25% practice open defecation. In addition to the census data, water analysis and visual inspection of the water-related infrastructure was conducted. In this case, on the slide, we see this was conducted in form of a transect work together with students and teachers of the local school in Tubicocha. And two important aspects of the collected information are presented here. First, in the left picture, we see the outlet of the wastewater. And wastewater was not treated. It was reused. It was reused for irrigation downstreams, and both domestic wastewater and also wastewater from a slaughterhouse are discharged to the river. And second, on the right picture, we see a little pond, and the little ponds, they contain also wastewater, most probably because of leakage or wrong connections, and they are also used for irrigation purposes, and both posing potential health risk to the people in Tubicocha. If we now evaluate Tubicocha regarding the achievement of SDG 6.2, it appears that the target proportion of population using safely managed sanitation services, including hand washing facility with soap and water, are not met. The indicator is structured in form of a service ladder. The joint monitoring program between World Health Organization and UNICEF is currently responsible to monitor this target. And the definition of safely managed includes that excreta should be safely disposed in situ or transported and treated offsite. And this is not reached since there is no treatment of wastewater. The classification for Tubicocha ranges between basic and open defecation, and this depends on the percentage of the population with the corresponding sanitary infrastructure we just saw on the previous slide. And similar, it applies for the SDG indicator 6.31. The SDG 6 targets, they are largely interrelated, and the results of the previous indicator 6.2, they serve as input data for the evaluation of this indicator, proportion of wastewater safely treated. And in order to calculate this proportion, the percentage of wastewater that is, the drinking water consumption and the sanitary infrastructure, its condition, possible collection and transport, these are all required input data. They, on the left side of the matrix, the indicator evaluates the wastewater treated with this input data. And currently we have to say that there's no treatment, so Tubicocha has a wastewater treatment of 0%, and this indicator is not reached. So if we shortly summarize, there is existing sewer connections in the village center, but wastewater is not treated. It is used for irrigation downstreams or through ponds. And what we actually have is unsafe wastewater reuse. Either if it's wastewater disposal or safe reuse, no matter what, there should be suitable technologies. And to be considered should be primary sedimentation for solid removal, activated sludge process or trickling filter process, disinfection, for example, by a slow sand filtration. And this is especially important for later reuse of the water. And then the sludge should also be considered. Like if there's sludge treatment, it could be, for example, anaerobic treatment. Then, of course, there are also challenges, especially also the same as for the drinking water side, especially regarding operation and maintenance and monitoring of the parameters, physical parameters, chemicals, and biological parameters. And to overcome these challenges, practical training for the HAS would be important, as well as training for the ATMs. These are communal offices which give support in form of technical assistance, for example, to the HAS activities of the community, and maybe also the integration of the health center, Puesto de Salud, in Tubicocha for monitoring or quality control could be an important measure. Our proposed concept, as they already use their wastewater, is a safe wastewater reuse with a treatment with a trickling filter because of its low energy consumption and its stable process operation. First, there's the denitrification tank, then a sedimentation tank, a trickling filter, a second sedimentation, and at the end, a slow sand filter. The volume fluxes given here are dimensioned for a small pilot plant, which we started to construct in April this year. Together with the HAS, the plant was partly built up to serve as a training plant for the HAS to collect additional design data for more precise planning for a large-scale plant, and with the additional benefit to use the treated water at the end for irrigation purposes. And the support of the community during the construction was really great. There was a lot of interest on how the system works and also great hope to improve the situation at the village. But unfortunately, the work could not be continued because of the lockdown in Peru. And yeah, that was my side on the current situation in Tubicocha and the possible reuse option we decided could be a solution for them.
Thank you very much, Hannah. So now we still have time for discussion, and I dare to switch to a discussion mode once again. Let's see if it works. So now, in theory, everybody should be able to unmute him or herself. Let's see if that works. Lilith, could you remove that presentation? I don't know. All right. So if you have a question or a comment, please just put your microphone on. I hope it works now. And just ask, please. Is that working anyway, or is that not working? Lucia or Manu, could you try if you can say something?
If I could say something, maybe we should try to go into the question and answer mode.
Okay.
Maybe that works better.
Let's try.
Okay.
Okay. Could you do that for me?
Yes.
So now.
And I would prefer to leave the meeting, go to the webinar mode.
All right.
Maybe this blocks something.
Yeah, it looks like. What a pity. Okay. But I think, yeah, let's try the Q&A mode. So
And now if someone clicks on the micro next to their name, they should be able
to speak.
Yes.
We hope. Okay, Manu writes, I cannot start video or audio. So please type your questions into the chat. That's the last possibility we have, I think.
Maybe also you can try to unmute the people. For example, Manuel Kraus, I will try to unmute him. Now he should be able.
Tja, Lilith, you try to fix that, and I start a discussion here among our team members, perhaps. Let's do that. Is that an option? So there are 2 points that we frequently have discussed in the Trust project. The one is the crucial question, how to make these solutions durable, and how to make concepts or plans that are developed or implemented by research projects more sustainable and long-term solutions. Michael, Hannah, Fabienne, Christian, what are your thoughts on this?
If I just go in order of the presentation, I'm starting, and if anybody wants to comment something in the chat, that seems to work, so maybe that's an idea. Yeah, I think what we found, it was really important that we have the integration of the most actors possible, since we found that there were many actors acting along each other and also cooperating, but not all the actors were cooperating with each other. So from our side, it seemed a very important step to, first of all, get everybody on the same page and get them working together. We also found that on a local level, there's a lot of turnover in the personnel. So it's also an important factor on how to really have a consistent kind of integration of all the actors, because they may change in the next legislation period and there may be another priority. So it seems to be an important challenge to get everybody on board, and also on a long-term level.
Yeah, thank you, Fabienne. And from the technical side, Michael?
I think from the technical perspective, it's very important in these villages that we have simple technologies which can be managed by the people. For example, if we would do a fancy membrane filtration in this village, it would not work. It would easily block and then it will be damaged or something like this. You have to use simple technologies which you build together with the community in order that a community can manage it and they know how it works and how it is maintained, basically. And you need, of course, to take the people with you, and that you can show them the value of the methodology, that you can demonstrate that they now can safely drink the water, and that is a very easy and manageable technology. I think this is an important point, and I think the very nice thing about this project was that we have also this social point, and to include the people in workshops in Tubicocha in order to get this together and to get the community think about the problems and the possibilities, and to work with the community together.
Would you like to add something, Hannah, to this point?
Yeah, I think the same. For example, like, it was a great experience constructing this pilot plant, but without all the work before, with the different groups and stakeholders meeting, and who is the owner of this site, and they have to talk with each other, and they have to know what's going on there, it would not be possible, I think. And then later to see the questions they had when we were constructing it, really, they were eager to learn something as well. But for the wastewater side, they quite often ask about what is with the drinking water plan, because their priorities for them, drinking water is the first issue, and then comes the wastewater side. So that's why for us it was also important to have a real benefit for them, not just the community downstream, let's say, who will benefit from clear streams and rivers, but to really maybe use the water for irrigation and have a safe way to use the wastewater.
Yeah, great. Dear visitors whom I cannot hear or see, if you want to join in, please put your questions and comments into the chat, and Christian will bring them to me and to my colleagues. Okay, I'm very sorry for that. I have no idea what is happening. I see that Adelphi is typing that they are trying to solve it. That is good. So you already said, Hannah, that there are priorities on ground, and that drinking water might be have a bigger priority than wastewater treatment. This is another issue that especially you have been discussing, if we should give a priority to safe wastewater disposal, or if we should strive for safe reuse, because wastewater is informally reused anyhow. So would you like to add something? What's your point of view?
Yeah, we decided for the reuse option to have this gain for the community itself because of the safe reuse of the wastewater and because they're doing it anyway. So drinking water is the priority, or they are the impacts on unsafe drinking water. They feel more direct than the impact on unsafe wastewater. And then if somebody gets sick, was it because of the salad, which was irrigated by wastewater, or was it because of the drinking water with the bacteria in it? So it's not easy to say for them, but drinking water is really on their mind. But because they use their wastewater for irrigation, so water in general, to save water, to have enough water, it is a topic. And therefore, we do think reuse is.
So I think to add on this, I think it's important to have both sides looked at, because from the drinking water, the people are aware of the problem and they usually boil the water, which is fine that they can consume it. But as Hannah said, with the salad, which is irrigated with wastewater, and they don't really clean it appropriately, so they get ill from the salad. So I think it's very important to include both views, and that was I think a really good thing within the Trust project, that we look at a whole water cycle there and try to look on the quantity as well as the quality of the water and try to improve both for this village. And so it's a real pity that we couldn't start to get the drinking water pilot plant also there, and also to don't finish the wastewater pilot plant.
Yeah, definitely. Fabienne or Christian, would you like to add something?
Yeah, just maybe before we got to this question, just my point of view also, that it was very important to first of all get an idea of what are the practices that are in place at the moment, so that we can adapt the technical concepts to those practices. So we can ask, how can you reuse the water afterwards? How could we use it for like a small plant? Or so that was an important factor, that we could use it for so that it was adapted to the lives of the people and having a real life benefit, and it was important also for the concept development. Yeah.
So I see that we have questions in the chat. Christian, would you bring them in, please?
Yes. Can you hear me? Yes. I see one question from Sebastian Sturm. Do you see any chance to raise the value of safe drinking water in community and to strengthen the role of HAS in the local society? That's a question maybe to Michael and to Fabienne.
Yeah.
So,
do you want to? Okay. Yeah, I think from our point of view, we found that there is a lot of importance, first of all, to get access to water. That seems to be the first step, like to have a domestic access to water. Then there seems to be a second step, that is the water quality, which seems to be of a little less priority for many people, since they do not see the water quality. So from one side, it would be important to get a consistent water monitoring, the monitoring of the water quality, which seems to be an issue, so that the circle of monitoring and improving can be restored, which seems to be a problem right now. And then hopefully getting a better water quality, better quality of service, and at the same time also enhancing the awareness for what are all the steps that go into providing such safe drinking water, may enhance the appreciation of the communal organizations and also the work they do. So it would be monitoring the water quality more closely, and also working on environmental awareness and education.
So maybe I add on that. I think an important point is also to raise the value of the water in providing other concepts for financing, because at the moment it's a problem, as I told, that the HAS doesn't have a lot of money, and the water is cheap basically, and the people are aware, of course, sometimes of the value of the water, but still the toilets are flushing all the time, for example, because they're broken. They don't have a metering based system for the value. They have just a fixed price for the water. So in order to strengthen the water quality and to strengthen, of course, the HAS, they should provide another concept for financing them, and I think with that they will also be a little bit. So at the moment, I think they are not at the top of the institutions there. So they are. So I think the HAS is not so important as compared to other, like the community of the farmers, for example, or so. So that's definitely a way how we should how it could be tried to get them more involved in the HAS, I think.
Okay, thank you.
Yes, one further question from Manuel Kraus, FEW. How can the results and concepts be transferred to other areas of Peru or South America? So not regarding the results maybe, but the methodologies, the concepts of our project, how could they be transferred to other regions? Who has an idea?
I hope they will be transferred, because I think Tubicocha is really a typical situation for a lot of rural communities in Peru, and how I think at the end the publicity, or if NGOs or other we work close with organizations in Lima, and had involved 2 NGOs also for the construction of the pilot plants, that it continues also when we're not there, and that the hope is really that they adapt on this, and they work in other villages, and they get an idea, and they learn also on how these concepts could work. And sadly, with Corona, it changed a little bit our plans, but they really the idea was to use them as training pilot plans for NGOs and for the HAS and for the people there, and also with a guideline, and then to bring it to other places. I think it's important to have really local partners that transfers to other cities, villages.
And maybe also adding, I think what is an advantage of our approach was that it was very focused on finding solutions that are adapted to local context. So you have such a high heterogeneity between different areas, for example, of Peru. If you compare the Sierra region of the mountains with the rainforests in the Amazonas, so there's such a huge difference on how the supply is, how the local conditions are. So that is an advantage of this approach, that you focus on local conditions and look at what are practices and what are the practices of the people, so that you can adapt it to what is really needed at a local level.
Yeah. So you mean to contextualize the approaches anyhow,
yes.
And that the specificity of the approach was that it was so focused and so tailored to the specific situation as well. No?
Yeah. Mm-hmm. And by this means also getting together many different aspects that otherwise you might not have been able to.
Yeah. All right. Are there any more questions in the chat, Christian?
No.
So last chance. If there's nothing, I would say it's 3:00 sharp. So I'm very sorry that we didn't really enter a discussion with all of you. So still, thank you very much for your interest. And of course, you're invited to contact us or to visit us at the Trust exhibition booth and to begin or to continue a conversation with us, the Trust team. Thank you very much.
Yeah, also a few words from the Delphi side. So